Excuse me, is there anyone else on campus?
Is there anyone else on campus?
Yep, in your classroom?
I have one person to show up. Yep.
I might show up on Thursday.
Okay. All right. Mhm. Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone's doing all right. So sorry about the tardiness. Had a few technical difficulties for some reason. Internet wouldn't connect, but I figured it out, made it happen, and we are ready to roll. Good afternoon. Good afternoon. All right, so let's go ahead and get in there. Hey, how's it going? Hey, man. Quick question, right? Hold on a second, guys. Well, I don't know. All right, guys, so let's look at 5.8 today. Don't let me forget to tell you guys about Thursday. Oh, this is 5.7, 5.8. All right, so let's talk about applications of trigonometric functions. I need to erase some of this stuff. I don't know if y'all can hear that, but yeah, people are kind of loud right now. But we want to solve the right triangle for the missing pieces. So here's the triangle right here. You see it okay? Or is it glare? If you want, you can cut out the light. Okay, okay, cool. So they give us angle A and they give us side B. And they want us to find the missing pieces. So we need side A, side C, and angle B. Now, because it's a right triangle, see that little square in the corner, then we know we also have angle C as well, which is 90 degrees. So over here, you see, I just wrote the pieces that we have and the pieces that we do not have. Give you guys a chance to copy down the information. All right, so let's look at the first piece. You notice the easiest one to go ahead and find is angle B, because if you know two angles, then you can find a third angle because all of your angles of your triangle add up to give you 180 degrees. So we'll just subtract both A and C from 180, and that'll be 55.5 degrees. All right, any problems with angle B? Next, I go to find side A. And you want to start off with the information that you have and put yourself in position to have all of the pieces of your information or all the pieces of your relationship except for one piece. So I decided to do tangent of angle A. Angle A, if we go back here, I'm going to scroll back down a second, but angle A is 34.5. We're looking for side A. and we have the side that's right beside it, adjacent. So tangent, remember SOHCAHTOA, tangent is opposite or adjacent. So that's how I set this up over here. And so if you want it without the extra stuff, is tan of 34.5 degrees equal to A over 10.5. And so to solve for side A, we will multiply both sides by that 10.5. And side A is 7.2. 7.22. Always make sure also to watch my math lab directions. If they want 1 decimal place or 2 decimal places, they will let you know. They will be specific in what they ask of you. So make sure you watch that. All right. Also, when you're doing this, make sure that your calculator is in degrees. If you have your angle in degrees, make sure your calculator is in degrees. Because if not, if it's in radians, then it will give you a totally different answer, which would be incorrect. And then the last one, I use that same angle A and then do cosine of A because I need adjacent over hypotenuse. And if you look back at what we have here, angle is right here. And the side we know is 10.5, and then the hypotenuse is C. And that's what we're looking for. So we have cosine of 34.5 degrees equal to 10.5 over C. So now I need to solve for C, so you can multiply both sides by C. That gives you this, C times cosine 34.5 degrees equal to 10.5. Then divide both sides by cosine of 34.5 degrees, and that'll give you 12.74. All right, questions. Those are our 3 pieces. 55.5 for angle B. Yeah, how's it going? Side A is 7.22. Side C, 12.74. All right, can I scroll up? Everybody good? All right, I'll give you a chance to copy this down before I get into it. And that's my attempt at drawing this diagram out. For the most part, they give you the diagram. So that was my attempt of making that drawing for you guys. So from a point on level ground, 125 feet from the base, write some of this a little better. From the base of the tower, the angle of elevation is 57.2, approximate the height of the tower to the nearest, okay, approximate the height of the tower to the nearest foot. And I thought I did, no, I didn't. Okay, so let's see what I have room up here. I don't. I'll let you guys copy that and I'll scroll to the side. All right, can I do this over here? Everybody good? Just want to show y'all, just to re-emphasize this angle of elevation. Talking about your angle going up, elevating. And you also have an angle of depression. Hold on a second. All right. So angle of elevation is your angle going up. So I try to show direction here. And then they say angle of depression, then it will be your angle going down. So the difference between a positive angle versus a negative angle. We talked about your angle being a standard position. So this would be the same thing as a positive angle. This would be the same thing as a negative angle. Very good with that. Scrolling back to the problem. Okay. So looking at this diagram, and what we're trying to do is just from a point on level ground 125 feet from the base of a tower. So
Did something happen?
what you mean?
I
You
heard
just
a-
had a audio issue. You got really loud and fuzzy.
Oh, okay. Are we good now?
Yeah.
Okay, I'm gonna have to check the tape back and see what you guys heard.
Yeah.
Thanks for letting me know. All right. So all right, so we got the tower right here, and then 125 feet from the tower. It's right here. Try to signify that. And then it says the angle of elevation. So that's what's going down right here at this 57.2. And we want to know the approximate height of the tower. So that's what we have here. So based on the angle and the given information, that lets you know what trigonometric function you will be using. So you want to know A, so that's the missing piece, but you have 125 feet that's given, and the angle that you're dealing with. So you would use tangent because that deals with opposite over adjacent. All right. Just like before, when we had different pieces, we would switch the cosine if we were looking for opposite, adjacent and hypotenuse. So you have those three trig functions at your disposal to use accordingly. So go ahead, plug in. Opposite is A, adjacent is 125. You could have called AH for height. It's up to you what letters you want to use. Just want to make sure you are okay with what you're using. Multiply both sides by 125. 125 times tangent of 57.2 degrees. And don't forget, it said round to the nearest foot. So that's why we have 194. All right. Questions, make sure we're all right. Also, I didn't mention here, notice how this creates the right triangle in its shape. And, we have to have that in order for us to be able to use, the SOHCAHTOA tangent trig relationships, stuff like that. So, is everybody good? Okay, we're going to the next one. All right. A kite flies at a height of 30 feet when 65 feet of string is out. The string, if the string is in a straight line, just gonna write some of this stuff better. Find the angle that it makes with the ground, round to the nearest tenth. Once again, you have my diagram down here. I think I did all right with this one. All right, so the kite is 30 feet in the air. We have 65 feet of string that's out. We want to know what this angle is. So that's opposite and hypotenuse that we will be using in order to find. So that means we need to use sine. Once again, we're leaning on a SOHCAHTOA. And so sine is opposite over hypotenuse. So that's going to be sine of angle, and I just decided to call it capital. Well, yeah, because I call it sine A, so that'll be angle A. So sine A is going to be 30 over 65. And then in order to solve for that angle, we talked about sine inverse last class. So we apply the sine inverse to both sides. So that sine and sine inverse can cancel here. Leave me with just A. Sine inverse of 30 over 65 is 27.5 degrees. Once again, make sure your calculator is in the right mode. Make sure it's in the right mode. Questions? Any questions? Everybody all right?
Quick
Honestly.
question.
Yes.
You said the calculator is supposed to be in degree?
Yes.
Okay.
Yep. Say again? Yeah, most definitely. Right. And so for those who are wondering, one of your classmates was saying that she actually had that issue initially. So if your calculator is in radians, you will not get this answer. Yeah, and so if you have any issues with that, whether it's Zoom or whatever, you can always bring your calculator. Might be easier to bring it to an office hour, or if you decide to come in face to face, bring it in face to face, and we can make sure that you know how to use your calculator, or play around with it. And do
they have calculators at the school?
That I do not know. I do not know.
ask.
You can check with the math. I don't even know if it's called the math lab, but it's the tutoring center that we have here with Mr. Davis. And I know they did at one point, but I know COVID changes everything. So, but you can check with Mr. Davis and see if they have that as an option over here in the tutoring center.
Even if they don't, the TI 30X, this little one, this is really easy to get your hands on.
Okay, cool.
Scientific calculator.
Yeah, and that's a great point, because you don't need a TI 5000. You don't need
Yeah.
you don't need a graphing
things are like
calculator.
I found one that I saw online that I've been matched. I can find one for like $20.
Mhm.
Yeah.
Yep.
If you want to get a bigger one, look used.
All right, cool. Thank you, sir. Thank you. Yep. All you need mainly is a scientific, like your classmate was pointing out, scientific calculator, not necessarily a graphing one. All right. So the next one here, once again, I'll give you guys a chance to write this out. You can also try to find the way to set in degree in YouTube. I learned. Yeah, that's a great point as well. Thank you. T. YouTube solves all, right? So most definitely, if you have a calculator, make sure you know the model, whether it's TI 31 or whatever. Type in how to use TI 31 in YouTube, or just Google, and Google will take you there. Or how to change from degrees of radians and TI. If whatever you want to find, somebody has made a video, about it. So most definitely, thanks for that reminder. All right, so you are taking a balloon ride with your friend. Oh, I added way more to that. You are taking a balloon ride. Your friend is standing on level ground 100 feet away from your point of launch. At one instant, the angle of elevation from your friend is 31.7 degrees. All right. 1 minute later, the angle of elevation is 76.2. How far did you travel during that minute? All right, scrolling up some so you can see my diagram. If I scroll up too far, of course, let me know. Oh, my diagram is a little taller than I thought. All right, so there's my diagram. We have two triangles created, one for the short height or the short height of elevation, then one for the minute later, which is up a little higher. Do something, that should be 76. 71.2. Hold on 1 second, guys. I'm looking at this. I see 71.2 here, but I got 76.2 in my problem. Let me check something real quick. Text on me. Just want to confirm that number, if it's 76.2 or 71.2. Second, just want y'all stuff to be straight. Sorry, guys. Like I said, I just want to make sure this is correct. That's talking about the bearings. $76.2. I got 407. Yeah, so that should be 76.2 down there. 76.2 is correct. I just need to correct it down here. Same thing right here. All right. Sorry about that. I saw that mistake and I just wanted to correct it, but 76.2 is correct. All right, so let's look at what we have here. Once again, we're going to use tangent because of what's been given, opposite over adjacent. So I'm looking at the short height first, finding A. So I do tangent of 31.7 degrees. And then A over 100, because we have, the distance between my friend and my point of launch is 100 feet. And then you go ahead and solve by multiplying both sides by 100. That gives me 61.8 feet. All right, is everybody okay with the short height before we get to the taller height? All right, so the taller height, same flow. Now the 100 feet does not change because the balloon just goes straight up in the air, but it goes for a minute, so we are a little higher. And then we're doing the 100 times 10 of 76.1. I mean 0.2, excuse me. The 0.1 got me, that one. Got me seeing ones in all types of places. All right, so 100 times 10 of 76.2. That gives us 407.1. And then you notice in the red is what our answer really is. That's going to be the distance the balloon traveled in that minute. So the balloon had already traveled 61.8 feet. That was the shorter height. Then from the 61.8 feet, it goes up to 407.1 feet. And so you take the difference between the two. So it travels 345.3 feet. Any questions? Any questions? Anybody still copying before we look at bearings? All right, so in navigation and surveying problems, the term bearings is used to specify the location of one point relative to another. So the bearing from point O to point P is the acute angle measured in degrees between ray OP and the north-south line. I'll show you an example of that in a second, just give you the opportunity, right? Let's go look. All right, so if I say some of this stuff wrong and you know more because you normally deal with the navigation, you go boating and all the stuff like that, forgive me. I'm a mathematician, not necessarily somebody who's out on the waters. So the bearing from O to P is 40 degrees northeast. That's the only way I know how to say it. Maybe it's north 40 degrees east. Maybe that's the way you were gonna say it. Anyway, don't forget your direction. North is up, pointing up, south is pointing down, west is left, east is right. So if you're talking about northeast 40 degrees, you would go north and then go to the right 40 degrees. So that's what I was showing right here. So they put the north in front of the 40 and the east is second. So you think about that. So you go to the north first and then go to the right, which is east. So northwest would, you go up north and then lean to the left. 40 degrees for west if it was northwest. Oh, got one right there.
What does the last line say?
Say it
The
again.
one
Now.
with- What does the last line say in the definition? The one with the north and south line? Like
Talking about this
red?
right here.
Yeah.
Ray OP.
Oh, it's Y. Okay.
Yep.
Thank you.
Yep. All right, can I scroll up? Of course, if I go up too high, let me know. Yep, that's good before I go to the next problem.
Could you go up to the northwest thing up real quick? I didn't finish copying.
Northeast?
Yeah, okay, I got it now. Thank you.
No problem. And then this one, just another example. This one was southeast. So you go down south and then to the right. All right, going to the problem that uses bearings. Let me know if I'm going up too far. Anybody still holding on to that last one on bearings? All right. So we have a boat that leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. The figure shows that the captain then turns the boat 90 degrees clockwise and travels 18 miles on a bearing of south 48 degrees east. At that time, how far is the boat from the harbor entrance? All right, scrolling up. All right, let's try to make some sense of my diagram here. So the first thing it says that the harbor, it leaves the harbor and travels 25 miles on a bearing of north 42 degrees east. And so that's what's going on here. What's this purple? So that's what's going on right here. It's going northeast at 42 degrees northeast, 25 miles in that direction. Then going clockwise, 90 degrees, travels 18 miles with a bearing of southeast 48 degrees. So that's what's showing right there. So you're talking about south and then going to the right, 48 degrees. So then it says at that time, how far is the boat from the harbor entrance? So you're talking about this line right here. All right, so notice what I did. Oh, still have my eraser on. Okay. Notice what I said right here. Use the Pythagorean theorem because notice we have a right triangle created. And we have two sides, and we want to know that third side, the side that's opposite the 90-degree angle. Remember this side right here. Not going to sense me? All right, well, it's all good. We don't need it. So remember A and B are legs. So it's 25 squared plus 18 squared. So they could have went in either spot. But C needs to be on one side by itself. That's the one that's not interchangeable. That's your hypotenuse, the one opposite 90 degrees. So that'd be 625 plus 324. Give you 494. Take the square root of that in order to solve for C. And then it says you wouldn't use the negative because of measurement. So don't forget, whenever you take the square root of both sides, whenever you take the square root of both sides, there's a plus or minus that comes along with the square root property. But we would not have to consider the negative because we're dealing with measurement. So we have 30.8 miles. And that's how far the boat is from the harbor entrance. Got another question down there, but is everybody okay with finding how far the boat is from the harbor entrance? All right, so what is the bearing of the boat from the harbor entrance? Boat from the harbor entrance. So talking about this angle right here. And so, because that's where the harbor entrance is right here. So we use opposite over adjacent because we have these two pieces. 18, so tan theta is equal to 18 over 25. Use tan inverse in order to get theta by itself. And then tan inverse of 18 over 25 is 35.8, excuse me, degrees. All right, questions. And some questions may not come up until you actually try the stuff out on your own. So I understand that as well. So just seeing if anybody had any questions on anything I did up to this point, or anything I've done up to this point. Okay, everybody good? Everybody straight? Okay, so that is 5.8. Oh yeah, I forgot this other piece, my fault. I forgot the 42 degrees. Because remember, it's based on north. So it has to be northeast or northwest, north-south. So I need all of this right here. That would be the bearing. And so that was my fault. Forgot that last piece of the problem. So you add that 42 degrees that we already had, plus the theta we just found, and is 77.8. And so that's 77.8 northeast or north, 77.8 degrees east. Forgot about the last piece. All right. Everybody good with that? Everybody straight? Okay, so that's it for chapter 5 as far as lecture is concerned. Next class will be a review day, open for you guys to ask whatever questions you want to ask. It may not be Thursday though, because I may have an appointment that I cannot move. So I will shoot you guys an email no later than Wednesday and let you know what we're going to do. If we cannot meet on Thursday, I won't do anything. I won't send you a video or anything like that. It'll just be a day that give you the opportunity to get caught up. I was looking at MathLab a little bit ago, and I saw that we need some opportunities to get caught up anyway. So, so chapter 5, 8 sections. Your test, I believe, is already posted. We need to put a date out there, don't we? So this is the first. So the calendar. So normally I'll put it out there on the 13th, but that's Valentine's Day weekend. I don't want to ruin anybody's happy home. This class is Tuesday, Thursday class. So how about the 17th? So I'll give you to the 17th and knock out all of chapter 5. Now, next week, we're going to go ahead and get into chapter 6. So this date does not stop us from rolling on and moving forward, but that just gives you guys opportunity to get everything done out of chapter 5 without having to ask for an extension or anything like that. All right, so 2/17 will be the date that I have to adjust in MathLab for chapter 5's content. And that'll include all the homeworks and your tests. Don't forget your test review is not mandatory. Test review is extra credit if you were to get 85 or better. If you want 5 points added to your test. But if you go in there, look at it, then you do a few problems and you don't want to do any more, whatever you get on it does not affect you in any way. So, but I would suggest that you at least look at the test review because that'll let you know what's going to be on the test, type of problems you need to study. All right. Any questions, concerns, comments before we close? Everybody good? Straight.
No,
Are we,
we're good.
are we taking the test on the 17th?
No, you need to do it, hey, you need to do it by that time, midnight.
So we'll be doing it like on our own time, not during class.
Right, exactly.
I got you.
Mhm. So you're doing it just like you would just manage the times that you do your homeworks. It's just that when it comes to your test only you only get 2 shots, and there's not a help button like the homeworks have all those help tools and all the stuff like that. So that's the difference. So that's how that'll work for you. Oh, let me say this as well. Now the way the structure of the test is different as well as from the standpoint you can't go in and out of your test. So I don't think I had this conversation with you guys yet. If you get into the test and realize this was not the move to make, this is not the time, my brain is fried, whatever the case may be, if you want to circumvent the process, what you can do is just exit out of the test. Don't log off, don't hit save, submit, or anything. Just hit the red X up here and close out. That would treat it as if an interruption occurred, and then you'll be able to log back in and start back where you left off. So your tests, like I said, are not made so you can go in and out like that. So you will have to treat it as like a blackout. Someone just shut your computer off. If you do it like that, it'll let you pick up where you left off. All right.
Just to make sure I'm on the same page, the 17th is when all the homework, the review, and the test will be due, right?
For chapter 5, yes. Mhm.
Okay.
Yep. Most definitely.
Assignment was extra credit.
Say that one more time. I'm sorry.
Assignment was extra credit.
The test review.
Okay.
The test review is extra credit. Mhm. Yep. And you do not have to wait till the 17th to take it. Just want to reiterate that. You can take it. If you want to take it right now, you could. So it's open. All of chapter 5 is open, or it should be. So if you see anything different, let me know. But all of chapter 5 should be open. That includes your test review and your test. And don't forget to send me a copy of your scratch work of your test, not your homework, anything else, but just your test. Anything else? Anybody else? Everybody good?
No,
Can we
I'm
send
fine.
that scratch work through email?
Yes, email is fine. You can take a picture with your phone, take a picture with any smart device, or scan it, whatever way you want. Shoot it to me in the email. See what?
Bye.
All right, take care, sir. Take care. All right, so if you guys are good, I'm good. Have a great day. Be safe, and I will see you Thursday, unless you get that email from me. Look out for that email. You guys take care.
Thank you. Have a good
Hey,
day.
everyone.
Thanks. Do the same.
Thank you very much.
Take care.
Bye.
Bye.